Hello everyone, welcome to the explanation. So this video is continuation of our relational algebra part 3. Okay, so in last video we covered some operations like select operation, project operation, and union, intersection, and Cartesian. So in today's video I'll be covering the join operation in relational algebra. Okay, so I have already made a separate video for join using the SQL command. So the theory portion is same, the concept is same, the output will be same, only we'll learn here how to write this join operation using the relational algebra. What is the notation, what is the symbol for that? Okay, so I'll discuss very briefly here. So what is a join operation? First of all, a join operation is an operation that combines the rows of two or more table based on related column. Okay, so there are certain types of joins we have. First of all, we have got simple join, or we can say natural join. Okay, so first one is the natural join, we can say natural join. So natural join can only be performed if there is a common attribute between the relation. There should be a common attribute between the relation. So for example, let me write here, there should be a common attribute. Okay, so for example, it is considered two tables. So suppose there is a table A and it is going to contain, let me take a separate screen for this. Okay, so let us consider two tables here. So first table is table A, and here the attributes are, suppose this is one column number and this is the second column which is going to get the square of the number. So it is like this. Let us take another column. Okay, so it is again going to take number, that is be a B column. It is going to find the cube of the number, so it is 8 and 27, I guess. Okay, so what is the query that we are going to write for the natural joins? So the SQL query is very easy, that is select star from table A, and the command is natural join. And what you are going to join? You are going to join table A with table B using this natural join. So what will be the relational algebra for this? It is going to be select from table A natural join, and on which column you are going to perform this natural join. So as I told you, for joining we need a common attribute in both the tables. So you can see here the common attribute in this table is number A and number B. So here it will be num A equals to num B, and we are going to join what? Our table B. Okay, so here what will be the result table for this? So the result table will be, it is going to contain the number attribute, the square attribute, and the cube attribute. Okay, so let me not write here A and B, simply number. So it is going to contain 2, 3, the square will be 4, 9, and the cube will be 8 and 27. Okay, so that is the natural join. Now let us talk about another type of join, which is number B, which is EQUI join. Okay, so here EQUI join, what is the definition? So let me write the definition. EQUI join is a type of inner join in which we use equivalence, that is condition. This condition we are going to use in the join condition. Okay, so for this let us take our table, let us take our two tables, that is let me take some different table in this case. So first of all I am going to erase because I'll need the screen here. So let us take two tables. So our first table is Okay, this is our first table, which is our employee table. It has contained the attribute ID, name, department and salary, and the values are 1 2 3, John, Jane and Bob. Department are HR, IT and finance, and the salary is 5,000, 6,000 and 7,000. Let us take another table, which is our department table. Okay, and it has got the attribute as department ID and department name. So 1 2 3 is our department ID, and the department name are HR, IT and finance. So you can see this, these are the two attributes, two column that is common in both tables, so we can perform our join operation. So if you write the SQL command for EQUI join, so the SQL command will be select ID, name, salary and department name. We can say we are going to select all the attribute from employee, and next is the EQUI join. Yes, so EQUI join, what is the other table name? Department. On, what is the common attribute that we are going to perform the join? This is the department from here and department name from here, I guess. Yes, so on employee dot department equals to department dot department name. Okay, so this is the DEPRT only because it is same here, depart. Fine, so what will be the corresponding relational algebra? Same, instead of writing select, we are going to write project, then same ID, name, salary, department name, it is same we are going to write here, and instead of writing from employee, we are simply going to write in bracket, we are going to write employee, and then we are going to put the symbol join. Okay, and on what attribute we are going to join? So we are going to write this condition, after this here, and in bracket we are going to write department. Okay, so that is for inner join. Now in next part we are going to discuss the outer join. So first one is left outer join. So the theory part of this left right outer join I have already discussed in the previous video, so please go and check there. I am simply going to show you what is the symbol or how it is performed in using the relational algebra. So left outer join. Okay, so what is the symbol? Suppose if you are going to have two tables, that is A and B, so the symbol will be like this. For left outer join it is like this, and B. Okay, so suppose if you have got two tables, customer and order table, and if you want to join, okay, so let me write the table name. Suppose you have got two table, first is customer and other is table, and the customer and the ID attribute is common in both the table. So how is the join performed? Okay, so I'm not going to explain in detail, I'm just going to write the query that how this relational algebra is written here. If you write the relational algebra for this, so how it is written? Suppose if you want to display the ID, name and salary of customer, so project ID, name and salary from here, from customer table. Okay, and then it is left outer join. Left outer join, on what we are going to perform this left outer join? Sorry, I think this symbol okay, this is the symbol left outer join. So on what attribute we are going to perform this left outer join? That is customer dot id equals to, okay, order dot id from table order. Okay, so this is the common attribute. id and id, they are common in both. So customer.id equals to order.id on this order attribute, and if you put this symbol, it is nothing but equals to left outer join. So what I taught you in left outer join, all the attribute from the left table and only the common attribute from the right table will be included. Okay, same thing if you are going to perform for right outer join. Same thing, instead of writing this symbol, you are going to write this symbol for right outer join. Similarly, for full outer join, instead of writing this, you are going to write this. Okay, so what will happen in right outer join? All the attribute of order and only the common attribute of customer will be displayed. And what happens in full outer join? All the attribute of customer and all the attributes of order will be displayed. Okay, so that was all about joins. So in next video we'll be discussing about some questions. Till then, stay safe.